Hi everyone, I thought we could take a look at Vectors Assignment 67 worksheet. This is a review of all the stuff we're supposed to be able to do from our Vectors mini unit. It would be review before we go and take a test on law of sines, law of cosines, and vectors. So we're told to find a plus b, 4a minus 5b, and the magnitude of a in each case. So number one, we're told that a equals 2 comma negative 3. We're told that b equals 1 comma 4. So if I want a plus b, I'm just going to add these two vectors together. 1, 4, add them together, and I get 3, 1. And that's a plus b. And then I want this other problem called 4a minus 5b. So 4a is going to be 8, negative 12. And then minus 5b is going to be minus 5, minus 20. And when we add 4a and negative 5b, we get 3, negative 32. And finally, we want the magnitude of a. Here's a. I'll use the Pythagorean theorem to find the magnitude of a. 2 squared plus negative 3 squared. Don't forget the square root. And you should get the square root of 13. Okay, that's problem number 1. Problem number 2, we're dealing with a equals negative 2, 6. And b equals 2, 3, and we're looking for those same things. So when I add them together, I get 0, 9. And when I do 4a, 4a equals negative 8, 24, and minus 5b equals negative 10, negative 15. And I add those together, and I get negative 18, positive 9. Okay, so there's 4a minus 5b, there's a plus b, and the magnitude of a in this problem is going to be the square root of negative 2 squared plus 6 squared, which is the square root of 40, or 2 root 10. Okie dokie. Problem number 3. 3, we're given a in special unit vector form, and we're given b in special unit vector form, 5j. And we want b 3i minus 5j. We want to add these two vectors together. We want a plus b, and that's going to be 4i minus 3j. We want 4a, which is going to be 4 times I plus 2j, which is going to be 4i plus 8j. And then we want minus 5b, minus 5 times this, minus 5, 3i minus 5j, is going to be minus 15i plus 25j. When I add these together, I get negative 11i plus 33j. That's 4a minus 5b. And finally, the magnitude of a is going to be the square root of 1 squared plus 2 squared, or the square root of 5. All right, that's problem number 3. How about problem number 4? Sketch. Ooh, we've got to sketch some vectors. Problem number 4, we're sketching a plus b. No, we're sketching a, we're sketching b, we're sketching a plus b, and then 2a minus 3b. All right, so a is given to us as negative 4, 6, and b is given to us as -2, 3. Okay, so let's sketch them. -4, 6 is going to be this vector. There's A. B is -2, 3. Huh. -2, 3 is here. Well, look at that. A and B are on the same, they go in the same direction. A and B are just scalar multiples of each other. Okay. Now what about A plus B? Well, if I take A and then I add B to the end of it, I'm now going to be out here. And what will that be? That will be -6, 9. A plus B. So this whole thing now, where I went A and then I took B and added it at the end of A, this is now A plus B. And then finally we wanted 2A minus 3B. 2A minus 3B. Well, let's think about that. Go back to our original. This is A, so 2A would be this long. And then this is B, but I don't want B, I want minus 3B. 1, 2, 3. So I want this plus this. Well, I think that's going to end up to be that. And let's see if we can prove it. So 2A would be -4 plus 12. And then minus 3B, minus 3 times this is 6, minus 3 times this is -9. And I add these together and I get 2, 3. 2, oh, look at that, 2, 3. It's not this one, it's this one. This is what I get when I do -2A minus 3B, because both of these are positive, right? -3 times this is negative times negative is positive, and 2 times this, 2 times this, yeah, I was right the first time, -2. -2, positive 3, yes, it really is that. Phew, my reality is safe. So that's -8, and that will make more sense. There's problem 4. We drew all the little bits. Problem 5, given the graph to the right, find and sketch the resultant vector, A plus B. Well, if I think about 5A as being 2, 0, goes over 2 and not up, and B as being -1, 0, and I add these together, I get 1, 0 for my resultant vector. So my resultant vector looks like this. I'm going to go over 1. There's my resultant vector. Does it make sense? Well, let's think about it. A went over 2 in this direction. B goes back 1. So there's B. There's A. If we went out 2 and back 1, we'd go out 2 and then back 1, we'd be here at 1. So that makes sense to me. There's 5A plus B. 6 says C minus E. Okay, C is the vector 0, 2, and E is the vector 2, 2. And we're subtracting. 0 minus 2 is -2, 2 minus 2 is 0, and here's my resultant vector, -2, 0. So what I'm saying is that when I add this vector and this vector, think about it, oh, I'm subtracting. So there's -E, there's C, let's go -E, and let's go C, and look where I am. I'm here at -2, 0. Okay, so that's part B. Part C says What would you get if you did b plus e? Okay, so vector b is that negative 1, 0 vector, and vector e we said was 2, 2, and so if I add these together, I get 1, 2. And sketch the resultant vector. Goes over 1 and up 2. There's the R for part C. And do we have one more? I'm sorry, for this isn't C, that's 7. This is the sketch for 7. Problem number 8, F minus B. Okay. 8, F minus B. F is 1, 2. B is negative 1, 0. And I'm subtracting. 1 minus a minus 1 is 2. 2 minus 0 is 2. There's my resultant vector, and a sketch of that resultant vector is R. I go over 2 and up 2. Okay, problem number 9. Find the magnitude and direction angle for each vector. Okay, so A, 9 tells me that vector A is negative 5, 0. Well, I know from the graph of this that I'm just going this way, 5. What angle is that? Theta A is 180 degrees. But we could always do this by doing tangent inverse 0 over negative 5, but that gives us 0 degrees. Yeah, we're not going 0 degrees. Remember, add 180, and then you'll get the correct angle. When this is negative or 0, well, in this case, when it's 0, I definitely want that angle, not that angle, because of this negative 5. Okay, and what about the magnitude of A? The magnitude of A is just going to be negative 5 squared plus 0 squared, which is the square root of 25, or 5. Okay, there's problem 9. How about problem 10? Ooh, it's given to us in special unit vector form. Well, that shouldn't change anything. 10. We've got A equals negative 4I plus 5J. So what do we want? We want the magnitude. So magnitude of A is going to be square root of negative 4 squared plus 5 squared, which is going to be the square root of 41. And theta A, the direction angle, will be tangent inverse of 5 over negative 4. Let's draw this and make sure this isn't going to be one of those add 180 cases. Okay, we're going left 4 and up 5. And so this is our angle here. Okay, so we'll do this on our calculator. Inverse tangent 5 divided by negative 4, and I end up with negative 51.34 degrees. Hey, guess what? That's not this angle, that's this angle. And so I need to add 180 to that. So if I add 180, my direction angle is 128.6566 degrees. Okay, there's problem number 10. How about problem 11? The vectors A and B represent forces acting on the same point. What's the smallest angle between A and B? Find the magnitude of that angle. Find the magnitude of the resultant force. And theta is the smallest angle between them. Okay, so I can think of this problem two different ways. One way I can think about it, and this is the way the book would like me to think about it, but this is not the way I like to think about it, is that you've got these two vectors. One has a magnitude of 40, one has a magnitude of 70, and the angle in between them is 45 degrees. And we know if we add these together, we'll get this, and we want to know about the resultant vector. and we want to know the magnitude of the resultant force. Well, if I do law of cosines now, I'm going to find this, and that is not the magnitude of the resultant vector. This is the magnitude of the resultant vector. So how am I supposed to find that using law of cosines? Well, remember that these angles are supplementary and 40, and so I could do magnitude of r squared equals 70 squared plus 40 squared minus 2 times 40 times 70 times cosine 135. That's certainly one way to do this problem, to find that. But remember, that wasn't given to me. I had to find that. I prefer, with this problem, given the same information, that we use that other method of describing vectors. And this time, I want to assign one of the vectors to be lined up on the positive x-axis. Let's make that the 40. And then we have another vector that is 70 and goes off at a 45-degree angle. So then I'm going to set up 40 cosine 0, sine 0, 70 cosine 45, sine 45. I get to choose this. I could rotate them and have them be anywhere, but I'm going to choose to line one of them up on the positive x-axis so that I know that angle. Okay, so what do we have here? Cosine of 0 is 1, sine of 0 is 0, cosine of 45 is root 2 over 2, so 35 root 2, 35 root 2, and we add down, and we get 40 plus 35 root 2, comma, 35 root 2. There is our component form of r, and we're looking for the magnitude of r. So I'm going to do 40 plus 35 square root of 2 squared plus 35 square root of 2 squared, and don't forget to take the square root of that. And I get 102.273 is the magnitude of r. And that's what we were looking for. I can find the magnitude of r this way with law of cosines, or I can find the magnitude this way, provided I choose to line this up on 0. I know that there's 45 degrees between these two, but that doesn't mean that, like, I could make this one be 10 and this one be 55. But I don't know those angles from the unit circle. So if I line one of them up on 0, the second one is 45 degrees away from it, therefore 45. Okay, two ways to look at that problem. I'm going to do subsequent ones like this if we're asked to do more, and yes, we are in problems 12 and 13. 12. We're told that A is 5.5 and B is 6.2, and we've got cosine 0, sine 0, cosine, the angle between them is 60, sine 60, and we want to add these together. Okay, cosine of 0 is 1, so we got 5.5, sine of 0 is 0, and then here, cosine of 60 is 1/2, so that's going to be 3.1, and sine of 60 is root 3 over 2, that's 3.1 root 3. So when we add these together, we get 8.6, comma, 3.1 root 3. That's r, and I want the magnitude of r, so I use the Pythagorean theorem on this. I've got 3.1 square root of 3, and I want to square that answer, plus 8.6 squared, and then I want to take the square root of both sides. And I get 10.139 is the magnitude of r. Okay, problem number 13. We'll set it up the same way. 13 is 2 cosine 0 sine 0, and then the magnitude of the other one is 8 pounds cosine 120 sine 120. So we end up with 2, 0, and cosine of 120 is negative 1/2, so that's negative 4. Sine of 120 is root 3 over 2, so that's going to be 4 root 3. We add these down, we get negative 2, comma 4 root 3. That's r, and therefore the magnitude of r will be the square root of negative 2 squared plus 4 root 3 squared, which is 48 plus 4, 52, or 2 root 13. Okay, there's problem 13. Again, you could have done 11, 12, and 13 with law of cosines. I just think it's easier not to. All right, magnitude and direction of two forces acting on a point given A and B. Find the magnitude and direction angle of the resultant vector. Okay, so we've got 90 pounds going north 75 west. And the other one is 60 pounds south 5 east. South 5 degrees east. And this is 60 pounds. And we want to add these two together. Well, let's first say that this whole angle is 90 plus 75, or 165. And this whole angle is 275. So I'm going to say 90 cosine 165 sine 165, and then here we have 60 cosine 275 sine 275. I don't know these from the unit circles, so I'm just going to do 90 cosine 165, close parentheses, plus 60 cosine 275, close parentheses. And I get negative 81.704. Okay, now what about sine stuff? I'm going to do 90 sine of 165, close parentheses, plus 60 cosine, 60 sine of 275. And here I get negative 36.478. Both of these are negative, so I know my resultant vector would be in third quadrant. And what am I looking for here in this problem? This is problem 14. Find the magnitude and direction angle of the resulting vector. Okay, so here's the resultant vector. And what about the magnitude of that resultant vector? So 81.704 squared plus 36.478 squared. And don't forget to take the square root of that. And I get 89.477. And were these pounds? Yes, they were pounds. And theta r, what's my direction angle? That's going to be inverse tangent negative 36.478 divided by negative 81.704. Okay, now think about this for a second. We know that this is in third quadrant, so this direction angle had better be a third quadrant angle, or I should probably think about adding 180 to it. So inverse tangent 36 negative 36.478 divided by negative 81.704. And I end up with theta r is supposed to be 24.059 degrees. No, it's not. You better add 180 to that. Plus 180, and we get 204.059 degrees for number 14. Okay, let's take a look at 15. 15 and 16 will be more of the same. 15 says south 17 west. So 270 minus 17 is 253 degrees, and that's 20 pounds. And then we've got this other force, north 82 west. This is 82, this is 90, so this is 172 degrees, and this is a much bigger force of 50 pounds. So even though I've drawn them not to scale, this is a much bigger force. Okay, so I'm going to say 20 cosine 253 sine 253, and then 50 cosine 172 sine 172, and add these together. 20 times this plus 50 times that is going to be my x component. 20 cosine 253 close parentheses plus 50 cosine 172, and I get negative 55.361. Now for the sines, 20 times that, 20 sine 253 close parentheses plus 50 sine 172, and I end up with negative 12.167. Blink. There's r. We need magnitude of r and theta r. Okay, if I do the inverse tangent here, again, if I get a positive number, I know I got a problem because these are both negative, which means my resultant vector is in third quadrant. So this theta had better be a third quadrant angle. If I do inverse tangent of negative 12.167 divided by negative 55.361, I end up with 12.395. No, it's not 12.395. I have to add 180 degrees to that. Plus 180 gives me 192.395 degrees. And the magnitude of r, when I use the Pythagorean theorem on this, negative 12.167 squared plus negative 55.361 squared. Don't forget to take the square root. Oops. Don't forget to take the square root of that answer, and I get 56.682. And I think those are pounds. Those are pounds. Okay, that was problem 15. And we've got one more like that, 16. I see there's just a couple more problems before we start word problems. So let's get comfortable with this. 6 pounds at 110 degrees. So here's 110 degrees. And we've got 6 pounds. And then we've got this other force that's 2 pounds at 21.5 degrees and only 2 pounds, so it's much shorter. 2. Okay, so 6 cosine 110 sine 110, and then the other one, 2 cosine 21.5 sine 21.5. Okay, we'll add those together and we'll get our resultant vector. 6 times this plus 2 times this. 6 cosine 110, close parentheses, plus 2 cosine 21.5, and I get negative 0.191. Remember, cosine of 110 is a negative number. Negative 0.191, yes. And then what about the sine stuff? 6 times this one, 6 sine 110, close parentheses, plus 2 times sine of 21.5. Both of those are positive, so I'm expecting this answer to be positive 6.371. So there's our resultant vector. Our theta r is going to be tangent inverse 6.371 over negative 0.191. Now think about where we are. This is second quadrant because the x's are negative and the y's are positive, and tangent should be negative there. Okay, so negative makes sense. Inverse tangent of 6.371 divided by negative 0.191, and I end up with negative 88.283 degrees. But wait a minute, my angle isn't in fourth quadrant, it's in second quadrant. So I better add 180 to this, and I get 91.717 degrees. That's theta r. And the magnitude of r, what I get from using the Pythagorean theorem here, 6.371 squared plus 0.191 squared. Don't forget to take the square root of that, and I get 6.374. Only slightly different than the y component because this has very little effect. Okay, so that's problem number 16. Number 16. Let's take a look at 17. The directions are different here. They say find the unit vector that has the same direction of A and find the unit vector that has the opposite direction. Okay, so let's think about the unit vector. We said that the unit vector in the direction of V was given by V over magnitude of V. So I need to find the magnitude here. We've got A equals negative 8I plus 15J. So the magnitude of A is going to be the square root of negative 8 squared plus 15 squared, which is going to be 17. Shh, it's an 8, 15, 17 triple. You should know your triples. And so then I've got negative 8 over 17I plus 15 over 17j. That's the unit vector in the direction of A. But what if I want in the opposite direction of A? Well, that just means flip the signs. Plus 8 over 17I minus 15 over 17j. I flip both signs to go in the opposite direction. Instead of going left 8 and up 15, I'm going to go right 8 and down 15. I'm going right and down. Okay, so that was problem number 17. Problem number 18 is a little more of the same. We still want to use V over magnitude of V, or in this case, A over magnitude of A. We've got 2, negative 5. The magnitude of A is going to be the square root of 29. And so then the unit vector would be 2, negative 5 over root 29, which would be 2 root 29 over 29, negative 5 root 29 over 29. Now, what if we want to go in the opposite direction? We want the unit vector in the opposite direction. If we want the opposite direction, then we change these signs. We want negative 2 root 29 over 29 and positive 5 root 29 over 29. All right, there's problem 18. What about problem 19? Find the vector that has the opposite direction of 8I minus 5j, opposite direction, so negative 8I plus 5j, and has a magnitude and is 3 times the magnitude. Well, the magnitude of this vector is 64 plus 25, or square root of 89. Okay, that's the magnitude of our vector, and we want something that's 3 times that magnitude. So you know what this is? This is that find V in the direction of W with the given magnitude of V. Remember we said W magnitude of V over magnitude of W. So I'm going to say that W equals Oh, opposite direction of W. Well, no, let's just do W. 8I minus 15J. So that's that. And the magnitude of W, we found out, was 17 when we used the Pythagorean theorem. But what does it say? It says in part A that we want 3 times that magnitude, or 51. Okay, and that's the equivalent for us of the magnitude of V. So V equals W, 8I minus 15J, times V over magnitude of W. These cancel, giving me 3. So V equals 24I minus 45J. But wait a moment, that's in the same direction, and I want to go in the opposite direction. Therefore, we want negative 24I plus 45J. Okay, it's not hard math, but there's a lot of vocabulary and thinking to go on here. All right, and part B for that problem is 1/3 the magnitude. So here, V, W, magnitude of V over magnitude of W. And we're saying the magnitude of V equals 1/3 the magnitude of W. So I'm going to replace this with that. And then I'm going to have W times 1/3 magnitude of W over magnitude of W. And I see those cancel. And what was our vector W was that 8I minus 15J. So I've got 8I minus 15J times 1/3. So V is 8/3 I minus 5J. But we want in the opposite direction. Therefore, we want V to be negative 8/3 I plus 5J. This is the opposite direction as W. Okay, there's problem 19 done in 2 parts, A and B. Problem 20, our first word problem. Let's switch to B. 2 forces, 220 and 180, are acting on the same point and differ by 52 degrees. So I'm going to line one of them up here, 220 pounds, and 180 pounds, and they differ by 52 degrees. What is the magnitude of the resultant force? Okay, so 220 cosine 0, sine 0, 180 cosine 52, sine 52. I'm going to add those together. So this is going to be 220 plus, I don't know 52 from my unit circle, so I'm going to do 220 cosine 0 plus 180 cosine 52, and I get 330.819. And then here, 220 times 0 is 0 plus 180 sine 52. I get 141.842. Okay, so there's my component form of the resultant vector. And what are we asked to find? We're asked to find the magnitude. So I'll use the quadratic formula, 141.842 squared plus, I didn't mean quadratic formula, I meant Pythagorean theorem, plus 330.819 squared. Don't forget to take the square root. Squared. Don't forget to take the square root. And I get the magnitude of R is 141. Square root of that answer. No, it isn't. It's 359.945 pounds. Okay, that's problem number 20. 21, sides of the parallelogram are 50 and 70, and the diagonal connecting those sides is 40. Find the angles of the parallelogram. Okay, so we need theta, and once we find theta, we can find phi by subtracting from 180. We know the cosine of theta equals 50 squared plus 70 squared minus 40 squared over 2 times 50 times 70. Okay, 50 squared plus 70 squared minus 40 squared divided by parentheses 2 times 50 times 70. And remember, that's not theta, that's the cosine of theta. Cosine of theta equals 0.8285714. We want the inverse cosine to figure out that theta equals 34.048 degrees. And phi, remember, is the supplement to that. Phi is 180 minus theta, so 180 minus that angle, and I end up with 145.952 degrees. Okay, so that's problem number 21. On the back of the worksheet, problem number 22, if the resultant of two forces is a force of 60 pounds, find the angle the resultant makes with each component force. Okay, I'm thinking this might be better to do with law of cosines because they just give me magnitudes. And we've got 30, 50, and the result is 60. And they ask the question, what angle does the resultant force make with the original force? So I want to find this angle, and I want to find that angle. Well, conveniently, I know the law of cosines and have side, 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 so I can find this, and because this is also 50, and I know the law of cosines, and I have side, 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 I can find that. Cosine of phi is going to be 50 squared plus 60 squared minus 30 squared over 2 times 50 times 60. So 50 squared plus 60 squared minus 30 squared divided by 2 times 50 times 60. And then we do the inverse cosine of that angle, and we find out that phi equals 29.926 degrees. That's this angle here, the angle between the resultant and force 2. What about cosine of theta? That's going to be 30 squared plus 60 squared minus 50 squared over 2 times 30 times 60. So I've got 30 squared plus 60 squared minus 50 squared divided by 2 times 30 times 60. And then I do the inverse cosine, and I find out that theta equals 56.251 degrees. Okay, so those are the two angles. Those are the angles that the resultant force makes with each component force. That's problem number 22. Problem 23. Two people are moving a tree. Two people are moving a tree. Cables at the ends shown. One person is pulling with a force of 200. The other person is pulling with a force of 100. What is the resultant force when the forces are applied between them at an angle of 35 degrees. Determine the component form of the resultant as well as its magnitude. Do not find the direction angle, please, in number 22. Just find the component form and the magnitude. Okay, so we know that there's 35 degrees between those two. So let's take a look at setting the problem up this way. 200, 100, 35 degrees between them. Okay, so I'm going to say 200 cosine 0, sine 0, 100 cosine 35, sine 35, plus. Actually, I want to take a look at this problem a second way when we're done with this. So this is going to be 200 times this, which is 200, plus 100 times that. So 200 plus 100 cosine 35. And I get 281.915. And then 200 times 0 is 0, plus 100 sine 35. And so that gives me 57.358. Okay, there's R, the magnitude of R. What do I get? I get Pythagorean theorem, which is 57.358 squared plus 281.915 squared. And don't forget to do the square root. And I get 287.691. Okay, now, and those are pounds. 287. Ah, okay. So it's not the 300 that would be the total of the applied forces. It's a little less. Now, I wanted to do this problem a second way because it felt a little arbitrary the way I set it up. What if I had drawn the picture this way? 200, 100, 35. Well, then we've got 100 cosine 0, sine 0, and 200 cosine 35, sine 35. And my question is, do we get the same component form and the same magnitude? So I'm going to figure this out. 100 cosine 0, close parentheses, plus 200 cosine 35, and I get 263.830, comma, 100 times 0 is 0, plus 200 sine 35, and I get 376.546, and this is not that. It's very different, very different. But what about the magnitude? So 263.830 squared plus 376.546 squared. And don't forget to take the square root of that. And I get the, well, I think I did something wrong because I'm supposed to get the same magnitude. But I didn't get the same magnitude. And I guess that doesn't surprise me that I didn't get the same magnitude. Let's think about this. This was problem number 23. Yes, it was. Okay, so I've got 35 degrees between the two of them. In both cases, I'm supposed to get the same magnitude, and it's supposed to be this magnitude. So my setups are the same. This one, though, is not giving me that magnitude, so I must have a mistake in the way I put this in. Let's go back and figure that out. So let's try this one, 100 cosine 0 plus 200 cosine 35. And I get that 263. Good. 100 times 0 is 0. 200 times sine of 35. 114.715. Okay, so these component forms are not the same, but let's check the magnitudes. So 263.830 squared plus 114.715 squared. Don't forget to take the square root. And yes, I do get 287.691 pounds again. So here's the thing. When they don't tell me how to set it up and they just tell me about the angle in between, I can't guarantee the same component form. Because clearly this person is going more to the right and less up than this person is going less to the right and more up. They're going to get different resulting component forms. What we're finding are two different, so this person's resultant form, resultant is this, where we did this one, and then this one, and then there's their resultant vector, and we went over a lot and up a little. But this person, they're going over only a little. Over only a little. I'm sorry, they're going over a lot and up more. And this person, feel like I want to say that we're rotating the picture. So what we're finding, I'm onto something, but I can't quite name it. But I do get the same magnitude. And so don't ask the question, how are you supposed to know which way to set it up? On a test, if it were vaguely written like this, they would only ask you for the magnitude, which would be the same in either case. Or they would have to clarify and not just say that there were 35 degrees between them, but which one you should write first. I will tell you that my default is to always put the first vector mentioned on the horizontal x-axis. Since this 200 was mentioned first, this would have been the drawing I would have gone with. Okay? All right. Now, what about 24? 24, we've got a motorboat. And we're trying to go across a river, and the river has a current. So you want to go across the river, but the river has a current that is pushing. So you actually want to put your boat over here. You want to head this way because this force, the force of the boat and the force of the current, when you add those forces together, you'll end up with, or if you add the force of the current and then the force of the boat, you add up and you end up going straight across. This is our resultant vector. This is the boat. This is the current. When we add the current plus the boat, we end up with the resultant vector. That's what we're thinking about. Now, the person in the boat must aim at 15 degrees east of north, which means that this is 75 degrees here. And we know the current is going at 180 degrees. And so I want to say 10 miles, 30 miles an hour, 30, cosine 75, sine 75, plus the current. Ooh, I don't know the magnitude of the current. Magnitude of the current, cosine 180, sine 180. And when I add those together, the result is the boat goes straight across. The result is cosine 90, sine 90. Okay, and then the magnitude of r. Now what they're asking me for is simply the rate at which the river flows. They just want this part. So let's see what we know. Now, the current times the sine of 180, that's just going to be 0. So that's not going to help me out so much. This would be a great way for me to find how fast the boat goes across the river, to use the sine stuff. Because then I could say 3 sine 30 sine 75. This is 0 times this plus sine magnitude of c times 0 equals magnitude of r times sine of 90 is 1. And so, like I said, this would all go away, and that's how fast the boat is actually going across the river. We know that the motor thinks it's going at 30 miles an hour, but really, because we're fighting the current, we're going to be going slower than that, and so we're multiplying 30 by the sine of 75. Okay, but that's not the thing we're trying to find. We're trying to find the current. So I don't want the choice that gets rid of current. I'm not going to be using sines here. I'm going to be using cosines. Now the cosine of 90 is 0. And 0 times this will be 0. And that's nice. So I've got 0 equals 30 cosine 75 plus magnitude of c times the cosine of 180 is negative 1. So I'll add the magnitude of c to both sides, and that gives me magnitude of c equals 30 cosine 75. 30 cosine 75 equals 7.765 miles per hour is the magnitude of the current. All right, 24. What about 25? 25 says an airplane with an airspeed of 200 is flying at a direction of 50 degrees, and a 40-mile-an-hour wind is blowing directly from the west. Okay, so the wind is blowing this way at 40. The plane is going this way, 50 degrees at 200 miles an hour. And we want to know what the resultant vector will be. Where does the plane actually go? This is the actual path of the plane. Okay, so let's see what we know. We know 40 cosine 0 sine 0. We know 200 cosine 50 sine 50. And what else? We want to add those vectors together. 40 cosine 0 is 40 plus 200 cosine 50, and I get 168.557. And then here sine of 0 is 0, so I just have 200 sine of 50, which is 153.209. Okay, now that's our component form. It's asked for the true course, so what angle are we going at? Theta r is going to be the inverse tangent. So inverse tangent 153.209 divided by 168.557, and I get 42.269 degrees. So we thought we were going at 50 degrees, but the wind blew us, so we're only going at 42 degrees. And what about our magnitude? 153.209 squared plus 168.557 squared. Don't forget to take that square root. And the plane is actually getting some help with the current. We're going faster than the plane was going just by itself. We're going 227.782 miles per hour. Okay, that's problem number 25. Let's take a look at problem number 26. 26 says two children are pulling on a sled. And I'm going to flip the picture around so that I'm looking at it this way with 22 degrees and negative 22, I'm sorry, 20 and negative 22 degrees. This is 10 pounds, this is 18 pounds, and here's the sled. And the result, the magnitude of the resultant force is how much the combined weight of the sled and child are. Like, this is pulling a certain amount, this is pulling a certain amount. When we add what they're pulling, that's going to be, this is what they're pulling. They're pulling just this, the child sitting on the sled. So we know that 10 cosine 20 sine 20, and we know 18 cosine negative 22 sine negative 22. And we want to add these together. Okay. So 10 cosine 20 plus parentheses plus 18 cosine negative 22. And I get 26.086. And then here I want 10 sine of 20 plus 18 sine of negative 22. And I get negative 3.323. And then I really want to know the magnitude of this resultant force, because that's the combined weight of the sled and the child. So if I do 3.323 squared plus 26.086 squared, and don't forget the square root of that, I get 26.297 pounds. That's how much the small child and the sled weigh. That must be a very small child. Very small child indeed. Good. Okay, 26, 27. 27 says a boat is moving 25 knots in the direction of north 68 west, and that was how many knots? 25. And then we've got across a river whose current is traveling 12 knots north 16 west. 16. So this angle is 16 degrees and 12 knots. Okay. Give the true course of the boat as a resultant component form vector and its direction angle. And then, oh, how fast is it traveling? So they want all three. They want r in component form, they want theta r, and they want the magnitude of r. Now, if we draw boat plus current, it's going to look like this, and there's our resultant vector. So we have a second quadrant resultant vector, and we should keep that in mind when we're doing our finding theta r. So let's see what we can say. How big is the angle? Well, this part is 90, and this is 16. So 90 plus 16 is 106. So I get 12 cosine 106 sine 106. And then 25, and how big is this angle? Well, this part is 68 plus 90 would give me 158 sine 158. And I add those together. Okay, let's see what I get. 12 cosine 106 close parentheses plus 25 cosine 158. And I get negative 26.487. And then I want 12 sine 106 plus 25 sine 158. And that gives me 20.900. Okay, so there's the component form, and it is in second quadrant because the x's are negative and the y's are positive. The magnitude of r, how fast is the boat actually going? I wonder if you think it'll be more than or less than the actual 25 that it thought it was going. 20.900 squared plus 26.487 squared, square root, second answer, is 26.349 miles per hour. A little faster. The current is helping just a little bit. Now, what about theta r? We want inverse tangent of 20.9 over negative 26.487. So inverse tangent 20.9 divided by negative 26.487. And I get negative 38.276 degrees. Guess what? That would be over here. I don't want that. I want that one over there. So I better add 180. Plus 180 gives me theta r equals 141.724 degrees. Okay, there's problem number 27. Only 3 problems left. 28. A boat leaves a dock. 2 boats leave the dock at the same time. One travels south 15 west. South 15 west at 8 miles an hour. The other travels north 28 west at 12 miles an hour. And how far apart are they in 3 hours? Oh, I want this distance. Well, if this is 28, then this must be 62. And if this is 15, this must be 75. Is it 15? Yes. So then, how big is this angle? 138, 137. So look here, we've got this triangle. 12, 137, 8. And we want this distance. To me, that's a law of cosines problem. I don't need vectors for that. I need d squared equals 8 squared plus 12 squared minus 2 times 8 times 12 times the cosine of 137. So 64 plus 144 minus 2 times 8 times 12 times cosine of 137. Yep. And take the square root. And I get that d equals 18.666. And the units here are nautical miles. How far are they apart? In 3 hours. Oh, this was nautical miles per hour. That's what a knot is. Times 3 hours. So I actually need this number times 3. Okay, so I get 55.998 nautical miles. Okay, there's 28. 29 says find the resultant force. And we've got this picture. Force 1, the magnitude is 8, and theta F1 is 50 degrees, and the magnitude of force 2 is 7, and theta force 2 is 80 plus 50, which is 130, and magnitude of force 3 is given to us as 5, and theta for force 3 would be that 130 plus another 70, or 200 degrees. So we can add these 3 forces together easy enough. 8 cosine 50 sine 50, 7 cosine 130 sine 130, and 5 cosine 200 sine 200. Okay. 8 cosine 50 close parentheses plus 7 cosine 130 close parentheses plus 5 cosine 200, and we get negative 4.056. And now we want to do the sine stuff. 8 sine 50, close parentheses, plus 7 sine 130, close parentheses, plus 5 sine 200. And I end up with 9.781. So what are we looking for? Find the resultant vector's component form, magnitude, and direction angle. So there's that. Theta r, we'll use inverse tangent of 9.781 divided by negative 4.056. And is this really going to be in fourth quadrant? One of ours was here, another one was here, another one was here. The result of all these adding is somehow over here? No, I don't think so. I better add 180 to that, and I get 112.523 degrees. And of course, the magnitude of r we can find with the Pythagorean theorem, 9.781 squared plus 4.056 squared. Don't forget to do the square root, and I end up with 10.589. Alrighty, that's problem number 29. And now the last problem. 2 tugboats are pulling a large ship. The larger one exists a force of 4,000, and the smaller one 3,200 on a course of north 30 east, so this is negative 30. If the ship traveled in a straight line, then what's this theta? Okay, so here's what I know in number 30. I know that 4,000 cosine theta sine theta plus 3,200 cosine negative 30 sine negative 30. When I add them up, this thing is traveling horizontally. And so I'm going to say cosine 0 sine 0. Okay, and here we want to find theta. Now, and I don't know what the magnitude of the big ship is. Some sort of big ship magnitude big ship. Okay. So what's going to be the easiest way to do this? To build a sine equation or to build a cosine equation? Well, the cosine of 0 is 1, and 1 times this would mean if I wanted to find how heavy that big ship was, not the tugboats, but the big ship that the tugboats are pulling, then I would use cosines. But I want to use sines because I don't know this, and I want it to go away when I multiply it by 0. So I'm going to say that 4,000 cosine, sorry, we're doing the sine stuff, 4,000 sine of theta plus 3,200 sine of negative 30. Was that really 30? 30, yes. Should equal sine of 0, which is 0. Okay, sine of negative 30 is negative 1/2. Negative 1/2 times 3,200 is negative 1,600. And then here we have 4,000 sine theta. So 4,000 sine theta equals 1,600, or sine theta equals 1,600 over 4,000. And if I do the inverse sine inverse sine of 16 divided by 40, I end up with theta being 23.578 degrees. And we're all done with problem number 30. All right, that's the end of our little mini unit on vectors. I hope you learned a lot. Vectors are certainly really powerful tools that we can use to help us out. Have a great day, everyone.